Algebra 2, target 28. I can simplify a rational expression using multiplication and division. Today, we're going to focus on the multiplying and dividing rational expressions. Yesterday, remember we talked about simplifying. Today we're going to take it one step further and multiply and divide. Remember rational expressions, that means fractions, so all the rules that apply to fractions apply to rational expressions. The rule for multiplication is you go across the top and go across the bottom. So for example, a over b times c over d, just multiply the top, the numerator, get a times c, multiply the bottom, the denominator, get b times d. If it is an expression, you do the same thing, go across the top, and if there's anything in common, you're going to simplify. Like here, the 10s are in common, the x's, and the y's. So let's look at a first practice problem. We got x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. Our first step is to factor. The x plus 2, that's linear, and there's a lead coefficient of 1, so that does not simplify, or that does not factor. The x cubed minus 27, that's a difference of cubes, so we're going to have to factor x minus 3, and what's left is x squared plus 3x plus 9 times x squared plus 3x plus 9. That doesn't appear to be a fraction, but remember you can make anything to a fraction by putting it over 1. Now we've factored, just like yesterday, we can simplify. Look for anything in common in the numerator and the denominator. They both have x squared plus 3x plus 9. Those can cancel out, and we are left with x plus 2 over x minus 3. Try this one on your own. Pause and try it on your own. So what we do with the first fraction, the numerator, you're going to pull out common terms. It looks like there's a 2 and an x in both terms, so we're going to pull out 2x. I'm left with x minus 5. The denominator, that's a difference of squares, so that's x minus 5 times x plus 5. The second one, x plus 3, that's as factored as it gets. And 2x squared, that's the same as 2x times x, because the x squared is x times itself. As we look, we can see that top and bottom here have an x minus 5, so we can cancel those. And top and bottom here both have 2x, so those can cancel. So the top is just left with x plus 3. The bottom, there's an x plus 5 and an x. And we finish, we'll distribute on the bottom. We get x plus 3 over x squared plus 5x. Pause and try this one. All right, on this one, let's rewrite this numerator here. I always like to write it in standard form, so I'm going to rewrite that so that the powers are in decreasing order. So that gives me negative 3x squared plus 3x. My denominator, I'm just going to rewrite that. And on the right side, everything's in standard form already, so we'll rewrite that. Now here, we want to look for stuff they have in common. I'm seeing that they both have a 3 and an x. I'd also like to point out that the lead coefficient is negative. So what I'm going to do is I'm going to pull out negative 3x, and what's going to be left is x minus 1. On the bottom here, we want to see what multiplies to negative 5 and adds to 4. That gives us x plus 5 and x minus 1. Over here, we want to see what multiplies to negative 20 and adds to positive 1. Again, we're going to have x plus 5 and x minus 4, because 5 times negative 4 is negative 20. 5 plus negative 4 is 1. The bottom is 3x. And then as we look for stuff that's in common, I see an x minus 1 here and here on the top and the bottom. In order to cancel, it got to be on top and bottom. Much like the x plus 5s are both on top and bottom. And you can also see we got a 3x here and a 3x here. Notice that negative sign did not cancel. So what's left is just then a negative 1. So we'll look through what's left. We got negative 1 times x minus 4 on top. On bottom, everything canceled, so that's just 1. We'll distribute to simplify. We got negative x plus 4. Try this one. Pause and try it. X plus 5 is factored as far as it goes. It's linear with a coefficient of 1. X cubed minus 1, that is a difference of cubes, so we'll rewrite that as x minus 1. Then x squared plus x plus 1. And this one, it's not a fraction as it appears, but we can write it over 1 to make it a fraction. Look for anything in common. Those cancel. And when we're done, we got x plus 5 over x minus 1. Now, dividing. The key idea when dividing is to know that dividing really is multiplication. You just have to take the reciprocal first. So for example, right here, we got a over b divided by c over d. We can rewrite that and take the c and the d and flip them and make it a times d over c. And then it's just multiply across the top, a times d, across the bottom, b times c. Same thing here. Take that, flip it, and make it multiplication. And if it's a variable expression, take that and flip it and make it multiplication. So let's try one. We got a division here. Your first thing you should do is take what's being divided and flip it. So we'll rewrite this problem as 7x over 2x minus 10 times, flip the second one, x squared minus 11x plus 30 over x squared minus 6x. And then we'll go into factor mode. 7x is as simple as it gets. 2x minus 10, they both seem to be multiples of 2, so we'll factor the 2. We got 2 times x minus 5. Over here on the right one, what multiplies to 30 and adds to negative 11? Well, that would be x minus 6 and x minus 5, because negative 6 times negative 5 is positive 30. Negative 6 plus negative 5 is negative 11. Here we're looking at common terms. We're going to pull out the x, and we're left with x minus 6. As we look for common terms, the x minus 5s go away. The x minus 6s go away. And the x's go away. And we're just left with 7 over 2. So that means any value you stick in for x, you'll get 3.5 all the time. Pause, try on your own. Now as we flip this one, remember it doesn't look like a fraction, but to make it a fraction you just put it over 1. So to flip it, we're going to make 1 over with 3x squared plus 5x. Now as we factor here, we got a lead coefficient of 6, so we're going to need to pull it out into a box. 6x squared negative 15. We'll multiply negative 15 and negative 6, or negative 15 and positive 6 is negative 90. How do we multiply to 90 and add to get 1? Let's take a look and try some values here. 90 divided by 10 is 10 and 9. So 10 and negative 9, that adds to 1. So it's 10x and negative 9x. And then we're going to look what's in common going up. That looks like negative 3. Going up here, they're both even. So it looks like 2x. As we go sideways, we got 6x squared and negative 9x have 3x in common. Going sideways here, we got 5. Let's just double check. We got 5 there and negative 3 there. They should combine to get negative 15, and they do. Okay, 5 here, 2x there. That should get me 10x. Okay, 3x and 2x should get me the 6x squared. 3x and negative 3 gets me the 9x. So that's my factored form for there. 2x minus 3 times 3x plus 5 over 4x squared times 1 over. These have an x in common, so we'll pull out the x. And we're left with 3x plus 5. Let's take a look. The 3x plus 5's cancel. That appears to be all that cancels, so we'll multiply across the top. We got 2x minus 3. Across the bottom, we got 4x squared times x, which is 4x cubed. All right, so in summary, to multiply or divide with rational expressions. Step 1, if you're dividing, change it to multiplying and use the reciprocal. So you're always going to be doing the same thing. You're always going to be multiplying. It just, if you start with division, you got to flip it first. Flip the second one. And then just like yesterday, you're going to factor. And the whole point of factoring is so that you can cancel, make your stuff easier. And then for today, we're finishing up. You're going to multiply. You're going to multiply the results across the top because they're fractions and across the denominators.